So yeah, so this is about anti-patterns, and it's targeted at open sourced ML research code, and I know that's it's a very narrow view at it. A lot of these things that I'm going to talk about are actually anti-patterns in other pieces of code as well. If you just look at open source code, or just in general, if you work at a programming company, you're probably going to see a lot of this stuff pop up. But in my experience, it shows up sort of with an increased frequency in code that's open sourced by researchers, particularly PhD students. And I want to start this with a very big, very important disclaimer: is that no matter how sort of quote unquote ugly somebody's code might be, it is still worth releasing. And this is a worry that came up a lot when I first sort of presented these anti-patterns in the Reddit thread that Lavanya mentioned. Is a lot of people were like, well, we don't want to create a situation where somebody would feel like their code would be judged, or they might not release their code because they want to take the time to clean it up. And so I want to make a big disclaimer here: like, released code, no matter how janky, no matter how unclean, is always, always, always better than unreleased code. Having said that, there's a number of things that can be done to make the code better without additional effort. And one of the arguments that I'm going to try to make, that I fear this presentation might not support as well as I could in the future, is that trying to avoid some of these anti-patterns would also make your research life a little bit easier, and the life of those that come after you and maybe inherit your code base and go from there. This presentation is a bit like this drawing because I sort of ran out of time. I got slammed with work, so bear with me here. A little bit about myself. I work at Simbe Robotics. I do computer vision for them, a lot of deep learning work, and a lot of the stuff that I'm going to talk about today is sort of coming from adapting open source code bases for use in Simbe Robotics, and sort of seeing these patterns repeatedly. As mentioned before, I also run a YouTube channel. It's mostly about things like Python and deep learning, and most recently I've been doing a series of streams on reinforcement learning. And then if you want, you can follow me on Twitter, and I'll combine TensorFlow compilation woes with memes on there. So I'm going to try to cover 4 anti-patterns. This was supposed to be 5 anti-patterns, and I ran out of time, so it's 4 now. And in order, these are monolithic configuration objects, and we'll sort of discuss what exactly that means in a second. But not just having monolithic configuration objects, but also nesting them deep inside your code. This is the actual anti-pattern, not just having configuration objects, that's fine, but nesting it deep inside your code is the anti-pattern. I've also seen people use argparse for configuration management in lieu of a configuration file. And so that's also something that I'm going to discuss, and what are some of the alternatives and what's wrong with that. There's also this notion that because ultimately you're trying to run your code, or give somebody to run your code, so you make a command line interface to make it easy, but then the code is only really accessible from that command line interface. So that's another anti-pattern that I see a lot, and I'm going to discuss that. And then sometimes people will write a function that takes in file names as inputs and then outputs some data in some output file, and that's it. It doesn't actually return anything. And then people adapt that code and they start using it that way. So they just sort of look for the file that should be created. And so that's another anti-pattern that I'm going to discuss. As discussed, there was a fairly robust discussion on Reddit about these anti-patterns. So if anybody's interested, just sort of search this in Reddit and you'll find the thread. There's a lot of opinions there. And the very first anti-pattern that I'm going to talk about, the monolithic configuration object, also seemed to be the most contentious. So overall, it's generally a good idea to encapsulate the various parameters of your machine learning model or your simulation or whatever you're doing into a configuration file. Configuration files themselves are really, really good. YAML makes them also very readable. I'm not a huge fan of YAML in general, but for this purpose, I think YAML is a very good fit, because they sort of read off. You can sort of just look at them and go, okay, I understand what these things mean, and what they're supposed to be, and then you can parse them really easily. So having a configuration file, even if it's a very large configuration file, is a great idea. And it also makes it very easy for somebody who's reading your code to sort of look at the file and go, hey, hello? I heard somebody said something.
You. We can hear you.
Okay, somebody, okay, it's fine. So as I was saying, having a configuration file is a great idea. However, and actually, there's not a however yet. Usually, what people will do then after that, the sort of the lowest common denominator way of using them is that you can just say, hey, open this file and pass it through a YAML parser, and then you can access it like you access a field from a dictionary. So the pros here are this is very easy, and that's why you also see this usually most often. The cons are there's no validation here. So if your configuration needs to be some minimum set of fields and parameters, nothing in your code here is able to verify that. And because of that, if somebody's trying to adapt your code, or maybe you made a new configuration and you forgot a field, you won't find out about it until you try to use it, which potentially can be much later in the run, and so that can be very painful. This is also mutable, may accidentally be changed in the code, and accidental mutation is unfortunate. And then there's intentional mutation, where people will change the parameters or the fields of this dictionary, or add or subtract fields from it in the code. That's just devious. And I would say, like, I know that feels easy sometimes to just pass a dictionary to a function and have it get a new field when it comes back. But please don't do it. It's tracking that can be very, very difficult, especially as your code base becomes more bigger. It's also a bit clunky to reference. This is really a personal taste thing, but in a dictionary in Python, you have to like write it in as bracket access with passing the field as the field name as a string, and it's a little bit tiresome. And then if you're working in Jupyter, or if you're working in a text editor, usually you don't get or at least immediately you don't get auto completion for these, because it has no way of knowing what's in the dictionary. So those are some of the cons for this. In practice, the way I see this used is, and I apologize for these slides, they're a little bit busy, but I'll try to go over them in detail. In practice, I usually see them used like this, where somebody has a main function, they're opening the configuration YAML, they're getting the object, and then they're just passing it straight through to a bunch of functions. So in this case, the configuration is being passed to make model. Make model uses a field from that, but then also calls make model base and passes the configuration there. Here, there's also a mutation. Instead of having some way of setting a default for this, the default is just none, and the default is set in the code. And then, there's a bunch more code here, and we have no idea how it uses configuration just by reading this function. And anyways, so then this returns a model, and then yet again, we do the same thing, pass it to train model, and so on and so forth. So, these functions, make optimizer, construct loss function, there's not a lot that we can learn about what they're doing or what fields they're using by just looking at this. We kind of have to dig into the code, really dig into the code to figure out what are the dependencies of make optimizer, what are the dependencies of construct loss function. Even this function train epoch is, you can kind of see, train epoch is supposed to train for one epoch, and it takes in the model and the optimizer and the loss function. But then all of a sudden there's this configuration. What is it using from here? Is there like something to do with loss function or learning rate decay that's in there, or what's going on? Probably it's using the learning rate, but it's not clear. So that's one of the biggest cons that I would say of this approach, is what parameters are important to any of these functions. And also, any function can silently change this configuration, and we'd never know. And that can potentially become problematic if that introduces a silent bug and you kind of don't know where it's coming from. It is very easy to adapt. And in the Reddit thread and in other conversations that I had with people, this was the biggest pro that everybody presented for this, big enough to where all of these other problems were worth it, which is that if make optimizer needed 2 or 3 additional parameters, now you can just add them to the configuration file, and you don't have to change the function call at all. You don't have to change train model, you don't have to change make optimizer, etc. And I think that's a valid argument for research code, but at the same time, like I said, at some point, one of these problems, especially the one where silent bugs can introduce, is gonna outweigh this. And I'll talk in a second about how some of the pain of refactoring can be made easier with modern tools. So 3 main problems. In summary, there's 3 main problems. there's clunky access to the configuration fields. There is mutability, and then function dependencies become very unclear. So how can we make it better? So as I said before, I think a more reasonable usage for any kind of configuration is to not pass the entire configuration object wherever possible. So in this case, train model now takes the model as an input, and from configuration, it takes learning rate. So now it's incredibly clear what's important to train model. And if somebody's trying to adapt this code or just understand what it's doing before they use it in their paper, it's a lot more straightforward for them to understand what each of these models or what each of these functions actually hold as an importance. This dictionary itself is still mutable, but at the very least, it's not mutable by these nested functions, at least in this example. It's also clear what the functions take as parameters. But as I said before, this may not scale to more parameters. Like if save model now takes like 2 or 3 additional parameters for whatever reason, this is not going to necessarily, it gets a little bit more difficult to do that. So let's talk about the refactoring then. That argument that, if make model base is going to change, I don't want to have to change this line. And yes, the left side that I'm showing here is definitely easier to change than the right side when you introduce new parameters that the function needs to depend on. This is strictly true, but the latter is only slightly more work if you become best friends with your editor. So here I'm showing an example of PyCharm, which is a fairly popular IDE for Python. And the example here, the GIF, what it's showing is that you had a function that had one argument, and then the IDE sort of helps you figure out where this function is being used, and then you can add more fields to it and maybe give them default values or not, however you want to do it, and it changes the usage of it all throughout your code. Here it's only in one file, but in PyCharm this will happen throughout your code base for that, like semantically for that specific function. And so this is a very powerful tool. So anybody that uses PyCharm, you already have access to this. And so if we make best friends with our editors, then this argument becomes a lot less weighty. I don't personally use PyCharm. I use sometimes VS Code and sometimes Emacs, and pretty much all text editors have some facility for you where you can search for a particular pattern throughout a code base and then make changes to that pattern. And so with varying degrees of finesse, you can do this in pretty much any text editor as well. And if you wanted to, you can do this from Bash as well if you're really interested in that. So that to me, like if you make your functions so that they accept only their dependencies as different arguments, then this 0.3 gets solved. And I'm sure a lot of people are still going to be very resistant to this and may not see the benefit of it. But at the very least, I've shown a potential way out where the burden of maintaining a good API is not as much as it seemed to be. So moving on, before I tackle these other 2 points, I kind of have to move on to point 2. Some of these kind of get muddled and bleed into one another, and there's good reason for that. So the second one is about using argparse as configuration management. And so to set the stage, this is actually from an actual repo, and I've tried to hide the identity of the person who wrote this, but he's a well-respected AI researcher anyway, so it's fine, even if somebody recognizes who this is from. Argparse, I've seen this pattern a fair amount where argparse is used as a configuration management system, and what that ultimately means is that people will have in the best cases, they'll have some sort of a function that parses all these arguments for you. In the worst case, this would just be straight up out in the main script. And what they're doing is they're using this add argument as a way to define the parameters by using the default value, right? And the nice thing here is that, first of all, this gives you dot access. So as soon as you have the parsed args, you can use them with the dot operator. So you get args.seed and etc. And then the way you've put it together, you might actually also get autocomplete here because your editor can now figure out what the arguments are supposed to be by following the argument parser object. And so you get dot access, you probably get autocomplete, and you get an obvious command line interface from this. As soon as you've implemented this, you get a command line interface for free. So what are the problems? Well, imagine this getArgs function, the repo that I took this from, this was like 300 lines. And those 300 lines are just encoding something that could be as simple as like a 15, 20 line YAML file, because they're just encoding the configuration. So the configuration becomes very difficult to understand at a single glance. The second problem here is all changes that you would make to how you're running this particular file or how you're running this particular script, they only happen through the command line interface now. So if you're using a tool like weights and biases, I know there's other ways to log this configuration in weights and biases, but if having a configuration file that maybe gets committed with your code, or you can sort of make copies of, that helps a lot with reproducibility of what you're doing. Whereas this, and then combining that with command line sort of just a call to this file, isn't necessarily very reproducible, because you might forget what command you used. You have to sort of go through your bash history and whatnot. On top of that, I'm reasonably sure, I didn't quite confirm this, but I'm pretty sure this is still mutable. So those are some of the cons of doing this. I am going to just assert this. I think I've shown enough of reason to do this, but I think that when choosing between argparse and configuration files, you should prefer configuration files. And I'll show some alternatives where you can get some of the same kind of benefits of argparse, but with configuration files. So one of the ways that you can gain .access back for your arbitrary configuration dictionaries is by just using weights and biases. So when you run the init in weights and biases, you can actually pass it. The code here is wrong, but you can pass it the configuration dictionary. You can also pass it the arguments from argparse, and then once you've done this, you can take the return value of the init and either look at the config field or the config static field. The only difference here is that if you get config, it will be mutable, but if you get config static, it'll be immutable. And there's a disclaimer here: determined programmers in Python always find a way to make something that is immutable mutable. So if somebody like that is using your code, then you don't have a prayer. But most of the times that's not going to be the case. So you can then set config equals to this config static, and now you'll have something that has dot access to all your fields, and you also have optional immutability. I don't think that you get autocomplete in your editor, but I'm not entirely sure. I doubt you would. The other potential way that you can get dot access back is my personal favorite. This is what I like to do, and that's maybe I can see this being potentially more work, but you also get data validation for free, which can save a lot of time and headache. And then you also get optional mutability, and you definitely get autocomplete and everything. So there's this library called Pydantic, and what Pydantic does is you can take this base model class from them, and then if you subclass that, you can write your configuration very, very easily in this sort of data class-like fashion in Python, and you can specify what the types of these are supposed to be, and then if you add this config class underneath it, you can set this parameter for allowing mutation. And so now I'm showing on the right, you can just take your configuration dictionary and pass it to the initializer of this configuration object by just using this double star operator, which is a standard Python way of mapping a dictionary to a bunch of arguments. And when you do this, it will validate both the fields inside your configuration, make sure they all exist, and then it will also validate their types up to a point. And so you get pretty much all the benefits with an approach like this, and then on top of that, you get free autocomplete. So if somebody's interested in sort of cleaning out their configurations a little bit, give a look to Pydantic. One of the cool things also is that you can create an empty object. Once you've written out your configuration, you can create an empty version of this, and then you can actually dump it out to a dictionary or dump it out to a YAML from this object directly. So that way you can create your empty configuration and then fill it out and go from there. Okay, so going back to the issues that we talked about for the first point, now we've sort of presented alternatives to all of these, and what are some of the ways that you can get around it. So moving forward, let's talk about the anti-pattern that I mentioned, where code, when you have a situation where code is only accessible through a command line interface. So what I mean by that is, and I don't know, maybe nobody here actually does this, but I have definitely seen this in a number of repos, where you have some entry point script, right? So in this case, this is the file.py or just main.py, and somebody will be parsing the arguments up top and maybe loading some configuration, same as the first anti-pattern, and then you just sort of start doing all the work. So you take the input file name from the configuration, do a bunch of different steps, and then take the result file name from the configuration and save it out. So the only pro here is that you're now set up to be called from a command line. And there's a lot of cons. So first off, it's very hard to tell in this file what is going on. It's very hard to tell what the dependencies of these functions are, or, various functions are. And then your main entry point just sort of is all of your main code. There's no abstraction. So this is sort of the only way that you can go through and use these functions. And then inputs and outputs are files. I'll talk in a second about why that's a problem. This becomes very difficult to adapt into some other code. Some of it is just because all of the cons that I mentioned with the configuration being passed everywhere. And then some of it is with the fact that, especially when these kind of files get really complicated, it's very hard to tell when something starts and when something ends. This might have multiple substeps that make that a little bit more confusing, or sometimes if else statements. And so a lot of these make, sort of create more mental burden on the person that's reading or adapting the code. So a slightly better version of this is you start introducing some functions. So now I can say, hey, I'm going to separate it out into a function, and that function takes in an input file name, a result file name, and the configuration. And then it's sort of doing the same kind of things, but now it's a separate function on its own. And it makes a little bit more sense now. You can see where the business logic is, and you can see where the argument parsing is, and then finally where the function is being called. So it's a little bit less hard to understand what's going on here. We can make the whole thing a little bit more usable by changing and refactoring the code a little bit, so that now the first step, so in the past two examples, this first step function was accepting an input file name. So it wasn't clear what the ultimate use here was. But now what we can do is we can make it so that it accepts an image rather than the file name of an image, and then abstract this whole thing out into a separate function that takes in an image as an input, and then outputs the whatever the output of this is, which presumably is text. I just sort of made it up on the fly. So let's say it's text. And then we can create a second function, which is specifically for exposing your command line interface. And in that function, you can accept a file name, because from a command line, that's the easier thing to pass, and then as well as an output file name. And now it's incredibly clear. You can see, okay, the only thing that this function needed was the image. So you can read the image, and then you can open the output file name as a normal text file and write to it. And so the whole thing is a little bit more straightforward now. And if now somebody wants to use this function, the do the thing function, it's easier for them. They don't necessarily have to rely on whatever library you were using in first step to load the image. They don't have to rely on the fact that you would be saving this. Maybe they just wanted to commit it to, some cloud bucket or something like that. So it's somewhat more clear. And then now you have a library function, and so it's a lot easier to adapt to somebody else's code. And it was a very small change in the grand scheme of things. This was supposed to have an image that it does not currently have.
It's the day of technical difficulties.
It's okay. messed up this slide, so we'll just
You're doing
pretend it
great.
never happened. We'll just pretend that this slide never happened, and we'll go to the
Cool.
next one. So removing inputs and outputs from the configuration. So the last thing, and this is sort of a me putting my own personal sort of touch on this, but if I were writing this, then I would not put the image file name and the output file name in the configuration. And this goes back to, like the actual meat of your run, its own configuration should not really include what data you were fitting. If you're because most of the times this is usually given for inference or something like that, where you're just trying to get the output for some image. The input there should not really depend on your configuration. The configuration, it makes more sense for it to be separate, and then your command line interface can expose what the input image is supposed to be and where the output is supposed to be saved. So this is not so much like, I think it's fine if people prefer putting the input sort of folder and the output folder or something like that in the configuration. But if I were approaching making this, I would make those separate command line parameters. It just makes it a little bit easier. And then for processing different files or different different sets of data from the command line, you don't have to keep changing the configuration. So that's the only change here, and it's easier with a boldface now to adapt to somebody else's code. The actual command line call, if you see on the bottom, becomes a little bit longer, but I think that's to the benefit, not necessarily to the detriment. A final bit of advice here is I really don't like argparse in general, and the reason for that is argparse is a great module. It was very helpful, very useful in my early career, but I started seeing these patterns with argparse, and sometimes unintentionally the way a library is put together becomes its own worst enemy. So in the case of argparse, it kind of encourages, even without intending this, it kind of encourages behavior like this, where you just have argparse in the global scope of a file, and people use the resulting object as in weird ways. So instead, I prefer anytime all of my engineers, as well as people that I ever advise, I always tell them to use something like Argh, or there's a number of other libraries like that. And what Argh does is it basically makes it so that you can take any function and you can expose it directly to the command line, so long as it's using input types that can be represented in the command line. So in this case, we just took the do the thing CLI function, and if you pass it through this function called dispatch command, it just immediately turns this file into something that you can access from the command line in the same way that you were doing it before. So it's usually a lot less code to do this. It's a lot cleaner. And there's a few more things that you can do with it. If you want to give more help messages, you can add a decorator here. But the best thing that, in my opinion, Argh does is that it forces people to write their codes as functions. And I think that has sort of a hidden benefit that goes a long way. Okay, so the fourth anti-pattern is implicit intra-process communication via files. Now, there was some confusion about this in the Reddit thread. I don't mean this as saying like, hey, caching to a file is bad. Caching is a different story. What I'm referring to specifically is, if we go back to that intermediate form when we were sort of working through this code and making it better, we had this function called do the thing, and it takes as an input an input file name, as an output a result file name. It doesn't return anything. If this is your function, if you ship code like this, and this is the function that you had as sort of the main entry point, and it's not calling some like sub function like we set up later, what's going to happen is that some poor downstream researcher is going to use it like this, where they're going to write their own function, then they're going to call this function with their input file name, which they may have actually saved in their own function prior to this file name. And then they're going to take whatever this output file name was supposed to be, they're going to open it, read it, and then do the rest of the thing they were trying to do. And I've seen this multiple times. And nest this kind of approach 2 or 3 times as more and more people adapt that code, and you get into such a hairy mess where it becomes very hard to tell what function is doing what and what files it's touching, where it's saving them. And yeah, so just please don't do this. it's very easy to take a function like this and just separate it out into a subfunction that is not relying on file names at all. It's just sort of taking in something from memory and returning something in memory. Anything like that becomes a lot cleaner to use and a lot more easier to adapt. And just like The Sopranos, this presentation is going to come to an abrupt ending because I kind of ran out of time. So that's what I got. What if you use a config.py and put all the config variables there and access them from that file, and something like import config? I think if you have a really, really good reason for it, like I said, in my production stack, I do have a really good reason for it, which is that my configuration is dynamically constructed based on some other parameters that come from environment variables that I don't have any control over. So in that case, I think it makes a lot of sense. But in the examples that I was giving in open source code, or in situations where your configuration represents things like learning rates and stuff like that people might want to change to iterate over, I think it's better to have a configuration file, because you can always copy and paste a configuration file somewhere else and make a new one and track those in version control. Whereas with the config.py, the burden of doing that becomes a lot more.